If you tried to find the area of the white triangle, that was good thinking, because the total area of this, it's going to land in this big square. The area of this square is 16. No, it's not. The area of the square, the 8 by 8 square, is 64. If you could figure out the area of the white triangle, then your favorable outcomes would be that area, and all the possible outcomes would be the 64, the total area of the whole region in which the dart could land. And if you did it like I asked and you paused and you tried this on your own, you would have had some trouble finding the area of this white triangle. You could use Pythagorean theorem to find, this would be 4 root 2, and this one would be 64 plus 16 is square root of 80, which is what, 4 root 5. But it gets a little messy, obviously. Not to mention, this would also be 4 root 5. I can call this the base of my white triangle, but I still don't know the height. I still don't know that altitude, because this is not, it's not given that this angle is a right angle. In fact, I can tell that it's not a right angle. Should I say that so confidently? Yes. Okay, so this is not the way to find this probability. There's a much simpler way. And this concept comes up a lot in problem solving. It's not easy to find the area of the white triangle, but it's easy to find the area of the gray triangles. And the area of the white triangle is 64 minus the gray triangles. So if I call this triangle 1, triangle 2, and triangle 3, because these are right triangles, area of triangle 1, 1/2 base times height, 1/2 of 4 times 4, so 8. Area of triangle 2 equals area of triangle 3, because we see they have the same dimensions, 4 and 8. And so rather than use 1/2 base times height, I'm just going to use base times height. 8 times 4, 32. I do that because if I find 1/2 base times height, each one of them is 16, but I'm going to add them together, right? So A2 plus A3 is 32. So the area of the gray is 8 plus 32, or 40. So if the gray triangles add up to 40, then the white triangle must be 24. So in other words, the probability of the dart landing on gray is 40 64ths. I know that can be simplified, but for right now I'll just keep it. I want to see all the possible outcomes of the entire area. The probability of white landing in the white triangle must be the complement, or 20 24 64ths. So sometimes it's not easy to directly calculate what you're trying to find, or what you want to happen, but it's easy to calculate what you don't want to happen. And if the sum of what you want to happen and don't want to happen add up to 100%, you can use that idea of complements to work at it from a different direction. And so the probability of white simplified would be 4, 6, 16, I guess 8. Well, I should have known 8. 3 eighths. 3 eighths. 3 eighths chance of landing in the white triangle. It was an unfortunate place to put that. All right, on your notes you have the definition of odds. Odds are also a ratio, but unlike probability, it's not the ratio of favorable outcomes to possible outcomes. It's the ratio of favorable outcomes to unfavorable outcomes. So if there was if I wanted to find the odds of landing on the white triangle, the favorable outcomes would be the area of the white triangle, which is 24. The unfavorable outcomes would be landing in the other area, any other area other than white, which we know is a total area of 40 for the gray. And so when you simplify that common factor of 8, you get 3 over 5. So there's a 3 to 5 odds of landing in white. The odds of gray would be 5 to 3. Odds are typically shown with the word 2 or as a ratio like this, and not as often shown as a fraction, but I'm fine with any form. Could be shown either way. This is just more of a standard convention for odds.